Hello world, programming is actually awesome. It's a kind of creative problem solving. I want to know how my computers function. I always have. I have a bit of a problem though. The modern world doesn't want to know how anything works. They just want quick solutions, farted out by AIs, and APIs sort of glued together in Docker containers at best. There's still a CPU underneath that mess, but even the CPU is far too complex for any one human to fully comprehend. Let's forget all that and go back to the 90s. If people can get nostalgic for playing DOS games, and for repairing broken motherboards, we can do the same for programming those same computers. I have a specific programming experience I want to recreate though. The same way people try and set up their ideal DOS gaming PC by researching which bits of hardware should go in it, what the case is going to look like, what they'll put on the machine, the boxes they stick on the shelving to make it look nice. I'm going for that whole sort of experience. Maybe you've got one of these machines and are looking for something else to do with it apart from playing games. So let's strip back 30 years of progress, pretend it's sometime around the mid-90s when the 486 was kinda new and some game called Doom was taking the PC world by storm. And also PC World was a computer shop that still sold computers. Welcome to the start of a new series where I learn 90s PC and DOS programming. And you're coming along for the ride. It's going to be a wild one because I have no idea what I'm doing. The whole point is to have fun learning and discovering techniques. I don't really have a plan. If you did this kind of thing back in the day, feel free to be a right pedant in the comments and pick holes in all my code and everything that I'm saying. And if you never progress beyond the classic 10-print hello program, join in. We'll be moving quite quickly to get to the good stuff, but I'm aiming this at the same kind of people that the computing books of old were aimed at. People that were interested and clever enough to figure it out, if the content was explained well. We'll ease ourselves into this. I'm not going to start with hardcore low-level assembly programming just yet. Let's get a development environment working first. Programming DOS has a few options. We can program on real hardware. Maybe you own some. You can use it if you want. I'm basing all this stuff off a kind of DX266, the kind of thing I had when I was a kid. So anything between a 486DX and a Pentium MMX will do. Another alternative is we can use DOSBox. And if you've got DOSBox on your computer, it'll probably work fine for this. To me though, it doesn't feel like a computer. It feels more like just like a DOS prompt on your computer. So that leaves me using a PC emulator. Not a virtual machine like VirtualBox or VMware, but an emulator like 86box that actually emulates specific pieces of hardware. Let's go to my PC and I'll show you how to install 86box and get it running. 86box exists for most operating systems. Comes in two parts, the emulator itself and a front end. You'll also need the BIOS ROMs for the machines that you want to emulate. So I'll show you that on my computer. So this is the 86box website here, 86box.net. And you just download like the stable version, read all the instructions, it tells you what to do, it's pretty easy. Once you've installed it, you'll need to install on a manager as well, otherwise it's really hard to configure it. I've got two machines here, so I'll show you the kind of thing we're trying to do. If I start this 486 that I've got, you can see it actually like properly boots up. It's showing like all the BIOS stuff and all the config sys and everything booting up. This is running FreeDOS. So here we are, and it's DOS like you remember. If I go into here, you can see I've got some C code and other things. So what I want to do is get it to a point where I can actually write some C code and just play around with it using a nice interface. And I'll show you how to set all this stuff up. Being DOS, you don't have to shut the thing down, you can just kill it off. So it's dead easy. In this thing, you just press add and you have to give it a name like that. And I'll do configure and then press add. And then this is what I was saying before, you can completely choose what type of machine you want to have. So we want probably a socket 3. And then you can pick your CPU type. So I've gone for a DX2 66. Memory will go for 16 megabytes because we can do. The display needs to be VGA. You probably want to pick something that isn't ISA, so go for a local bus. I remember having a Cirrus Logic of some sort. I think it was a 5429. Input device, we'll have a mouse. We'll just go for a Microsoft Serial mouse. Sound, we won't use it at the moment, but we may as well just have a Sound Blaster 60, that'll do. Network, we'll leave that alone because it's a bit weird. Storage, we'll have one of these. There we are, one of them. And now you need to create a hard disk, just like any other emulator. So all you do is you go new, and we'll call it something. And you have to pick the size. Now this is where you've got to be careful because this is DOS, you can't just go having a 10 gigabyte hard disk. Anything below 500 meg is what you want, because again it's DOS, it's not that massive. Floppy drives, we'll need some of them. So we'll have a 720K 1.4 meg disk. We'll also have a CD-ROM, and it's going to be an 86 box CD-ROM, that'll do. Right, now if I start this, it will boot up, does its memory check, whinges that the checksum is wrong for the CMOS because the battery is flat apparently. So if we press delete, we can go in here, and the date and time have been grabbed from my actual computer. We need to go into hard disk detection, save and exit setup, and it will now complain that there's nothing it can do because I've got a blank hard disk that's not even been formatted. There, he'll just sit here now like a lemon doing nothing. So the next thing that we need is an operating system. So what we're going to use is FreeDOS, which you can get from freedos.org, and you just want to download it. Now what we want to download is, we don't need all of FreeDOS. FreeDOS has got loads of extra stuff in it that we're not going to make any use of. Now you see it says here, if your system doesn't support booting from the live CD, try downloading this. So we'll download this as well, and we'll see what's inside that zip file. Okay, so yeah, we definitely want this legacy CD one because it includes a floppy disk to boot off and then a CD. Because we're actually emulating a proper old DOS computer, if I just go back into the BIOS and I go into BIOS features, it can either boot off the hard disk or the floppy disk. It can't boot off CD. So we'll make it boot off drive A. But we have to put something into drive A. So tools, oh wait, first we need to extract all this stuff. So go to media, floppy 1, existing image, go into downloads, legacy CD, boot disk, media, CD-ROM, and then save and exit setup. Want to make the window bigger. Filter method nearest neighbour, it's a bit crisper. And it says disk boot failure, insert system disk. Okay, some time has briefly passed and I've realised what my mistake was. Where it says FD controller, you've actually got to have one. This is like how accurate the emulation is. I didn't tell it I had a floppy drive controller. So the BIOS thought it had a floppy drive. I put a floppy disk in the floppy drive, but then I didn't actually have a floppy drive controller. See, now it'll do this, skip the memory test. And now it starts booting. This is what we're after. This is FreeDOS. I think what I'll do, this is going to take quite a long time, so I'll sort of time-lapse through this. There's not a lot to do, it's pretty obvious. So I'll see you in a bit. Right, so one little thing, they at least tell you that if you leave the disk in, it's already installed. There it is, it's ready, so all we have to do is take out the floppy disk. So that one and eject, and we may as well eject the CD as well. And then if we restart the machine, it should just boot up into DOS. It's got this menu system, so let's deal with this because none of this is relevant. We just want it to boot up. There it is. Right, all this is garbage that we can get rid of. We'll keep this bit. We don't need that. I don't care about any of those. we'll have that to show the memory. We'll need to do something to set the keyboard up if you're not American. Although it should have done the press shift and 3. No, well, see, press shift and 3, I get a hash. This is a thing with UK and American keyboards. The keys are in different places. Like there's a button down by my enter key, which is large, that if I press it, is the backslash, but my backslash key is also backslash. We can fix that by getting rid of all of this rubbish and having just that. We'll have a mouse driver. We want the CD drive. We don't want networking. We don't want the welcome thing. We don't want this end either. So there's a basic AutoExec full of stuff. We're in the config sys. We're not bothered by that. We don't want a menu. We do want this though. We will load one of these things. I don't know which one. It doesn't matter for what we're doing. Let's have that. So we've got some high memory. We'll load the shell into high memory as well. And now let's reset the machine. All we've done there is configured the basic DOS machine so that it's got some RAM and it's got some memory. So there you go. You can see that we've got some conventional memory. We've got 15 megabytes of XMS, 555k of base memory, which is not that great. We can probably do better. Do that. Have that high? Have that high one. When I was a kid, I used to spend hours trying to get as much base memory as I possibly could on my PC. That was like my aim. So what we got now? There we are, 605k, that's okay, that'll do. So we have a DOS system. This is really cool. We now need to actually get some development system on this so that I can actually write code. Let's go and have a look at what there possibly is. So by now, you should have a bootable DOS environment ready to be used. Since it's DOS, we'll have to cope with using weird ways of getting data in and out the system, because it emulates a DOS machine really, really accurately. It's not like VirtualBox, where you can install some host editions and guest editions and get direct access to the computer's hard disk, unlike the host machine. Or is it the guest? I always forget which one is which. Either way, you can't break out the emulator. So weirdly, what you've got to do is make a fake floppy disk image, put your data onto it, and then there's various tools in Windows and Linux that let you mount floppy disk images and get the data in and out of them. You can also mount a folder that then 86box can see as a fake CD-ROM, and that's what we'll use for getting data into the machine. So anyway, how do we do programming? What tools do we need? So let's go find out what's available. Now, I want to do this using actual period correct tools. With my Agon videos, some of you rightly pointed out that writing C on a Z80 machine was not the way it was done. Now, the average 90s PC was actually beefy enough that we can develop on the machine itself. So that's what we're going to do. You see, I was first introduced to programming in DOS using Turbo Pascal, and I spent quite a while hacking around in my AutoExec BAT using DOS Edit, like you saw me do earlier. So, to me, editing text in DOS involves using a full screen text editor that's blue, has menu bars at the top, those weird DOS text windows, and like a little strip at the bottom with what keys you can press. To me, that's what programming in DOS is. I want to recreate that experience. This is what I found and what I tried out. So I tried some assemblers. I found Masum and Tasum, and they're really nice, they're really low level, and I will play with those in the future. The next thing I found was Turbo C, and it's a very old version of pre-ANSI C. So let's avoid this like the plague. The different flavors of C will be a future video, I think, but not today though. So moving right along, we've got Turbo C++. And it was looking good. I was going to use that until I found DJGPP, which has got to be the most confusing name for anything, until you look up what that means. It's pretty much GCC for DOS. But it came out in the 90s, so it's period correct, and we're allowed to use it. So don't whinge that I'm using a Linux tool in DOS. We did this back then. It also works with an editor called RHIDE, which is exactly what I'm after. It feels a bit like cheating, I know. It's essentially GNU tools from Linux in DOS. And it runs in protected mode, which disables a lot of that funky antique PC functionality. However, it's what people actually used in the 90s, so it's valid. We can use this one, and half the internet shouldn't whinge. Those that do, tell me what I should use instead. So, let's go back on my PC, and let's get DJGPP installed. So installing DJGPP is quite easy, really. There's no installers for DOS programs, you just unzip them into folders. Okay? The most useful thing that you'll get on this website is called this zip picker. And it helps you know what you want to download. So you pick a suitable FTP site. I live in the UK, Canterbury will do. Right, I want to build and run programs with it. I want to use DOS. Don't want to be able to read the online documentation. I'm not that bothered. I want to program in C, probably C++ and assembler. I want to use that thing. Would I like GDB? No. And that'll do. Oh look, Allegro Game Library. Interesting. So, what do I need to download? I need these things. And there's the instructions of how to install it, and you literally follow that step by step. I'm not going to show you how to do that, because I'm sure you're all capable of reading and following. But once you've done that, what you'll end up with is something like the original machine that I showed you, that should boot up into DOS nicely, and it should have DJGPP installed. So what we'll do is we'll just fire this up and check that it's working. So if I type RHIDE, it should open. There you go, look at that. And if I type in GCC, something should happen too. There we go, fatal error, no input files. If you get that kind of thing, it's probably going to work. So now, we need to figure out what to do with this thing. Right, if you've never touched C in your life before, stick with it because I'll show you what to do. We're just going to go through making the most basic, simple program ever that just checks that everything is working. We're going to write the good old hello world. Okay? Like I said, you need a folder to store your work in, so I've made one called DOSDev, and inside there, we'll make a folder called hello. And then you type RHIDE, and you need to give it the name of a project, so we'll call it hello. What it'll do is open up this window like this. What you've got to do first is make a new file. And then you've got to save the file. And if you look, we're in DOSDev hello. We're going to call it main.c. We then need to add that into this project window at the bottom so that it knows when to compile it and what to do with this piece of code. At the moment, this is not in any project, so it won't get compiled. If I look at run, I can't run anything because it doesn't know what to run, and I can't compile anything because it's got nothing to it won't do anything. You can switch to this bottom window by pressing F6, and then you press insert, and you can move around this file selector by using tab. The mouse is not the mouse. Look, if I click on here, the mouse pointer doesn't show up. So keyboard, and then press escape. So I've now added main.c into this project. If I press F6, I can go back up here. So if you've ever done any vague C programming before, a basic hello world just looks like this. Now this is not a modern editor. It's sort of vaguely like one, but it doesn't have all the basic things that you're probably used to if you do any programming already. We're going to set this up a bit to make it a little bit more friendly. If we go to Alt-W for Windows, so every red thing, if you press Alt and a key, you can get these open. Every red thing is a keyboard shortcut. So if I go to options, it's actually what I meant. Go to environment, go to editor, editor options. Okay, we don't want to use tabs, that's good. And let's see if I can get this right. We want intelligent C indent. Tab size is 4. Fight me in the comments. And then we press OK. So now if I press tab, yeah, that's moved 4. But you see I have to press delete 4 times to delete that. Let's fix that as well. Should be an option in here. Backspace unindents. OK for OK. So for tab. Editor is confusing. You'll get it right eventually. Play with those options. Alt-O, environment, editor, editor options. Mess with the stuff. You'll figure out kind of what it's doing. Anyway, never mind. You've met the editor your own thing. To compile this now, we press Alt-C and we go to compile. And it's running GCC. And you notice the speed. It's a tiny little C file. It's clicking away like mad with its hard disk icon flashing away. This is simulating the real speed of a 486. This is what computing was like. So it's kind of chilled out. You've got to go with the flow a bit, okay? Just like sit and wait for the thing. Realize you've got a cup of tea that's going cold that you probably should have drunk earlier. Yep, that's gone cold. That tastes awful. We're not going to touch that again. What you're looking for is it saying no errors. We can now run it. So Alt-R, run. And it'll recompile it again because it always does. It's not a clever editor. You'll spend a lot of time waiting. And it's done, and it's quit, and it's done. Yeah. So what we need to do is make it so that we can see that. So if we go to Alt-O, environment, there is a way of making it show the user screen when it's finished. Right, so inside environment options is show user screen after exit. If you turn that on, and another thing you've got to do is actually save the options, otherwise it won't remember. If we run this now, okay, let's make it. Right. So it is actually working. It's just, I think when it draws this enter jump to source thing on the screen, it overwrites this. This user screen is not that great. So let's just add a little tiny bit more code so that we can actually see what's going on. Whoops. Right, if you type something that it doesn't understand and you get compiler error, you'll get this down in the bottom in the message window. And it's trying to tell you that in main.c, on line 6, C is undeclared because I've not used it. In here, I'm on this editor window. If I press enter on an error, it takes me to it. And I need to go char, like that. I will, if I remember, edit out all these long delays whilst it compiles. If I forget, just bear with me. It's hard like working out where these things are when I'm editing video. There was some editor errors. It doesn't know what getcha is. Did I mean get C? So sometimes the compiler is smarter than us and it actually knows what you try to type in. Another way of knowing what to type in is to get a book. So if you want a book, you need this book. C programming language and CC there. Okay, this is the C book that everyone talks about. There you are, you need that book. And in here, it tells you everything. Of course, all these errors and me fussing about is just to show how to use the editor, how to find mistakes, how to deal with them. Nothing at all to do with me getting things wrong consistently, despite having written C for 20 odd years. What's it whinging at now? Too few arguments to get C? Okay. We're going to break out the book. We're going to look at how to do this. Nope, get C is definitely not what we want because that's for getting out of a file. I must have looked at page 247 of this book quite a lot because it just opened on it. And it's all to do with character input and output functions. There, now, you see what it's done? It's run hello world and it's stopped. It's actually waited for me to press a key on the keyboard before it quits. Like K and enter. There we go. and it's now showing it again. So this is how you write C, how you edit it, how you compile it. This is a basic Hello World program, so if you want to type this in and run it, you can have a go. I'm going to make it a bit more interesting. So F6 to move up to the top window. Let's make a loop. Let's print this out a bunch of times. I put my brackets at the end of the lines. Again, fight me in the comments if you think you should do something else. If I run this now. There we go. Look, it's written Hello World 10 times along the screen. Let's do a one where it asks for our name. It's been a while since I've done this. Let me remember how to read text in. I want to read in a string. I know it's scanf, but I've forgotten how to do it. Yeah. Right, so we'll make a character array. We'll make it 50 long. And then we'll remember how to do this because, yep. Slightly embarrassing when you can't remember the basic things of C, but you could write this in Python in 3 seconds. So you may have noticed that I've forgotten how to do something in C, which is a little bit embarrassing to tell you the truth. I'm trying to resist the urge to just open Google and type it in. Like reading these things and like reading through it is what we did. And it's slow, feels a bit inefficient when I can literally just like ask something. But while reading through the book, you learn extra stuff. And I think that's something we've lost in like today's world of just hacking code together quickly to get a job done and just Googling words, or even now just typing stuff in ChatGPT. Like, I know I do that myself, but I'm discovering it's quite nice just to read a book because I'm finding random pages that show me stuff. So yeah, I'll come back to you in a minute. Right, so what we do is we do scanf, we're after text, and it wants to go into name. Okay, here we go. What is your name? I'll put in my name, and it quit. Oh no, there we are. It says hello and my name. Most basic little C program that you can write. There is a problem with C that will bite you eventually. I'm creating a character array that's 50 long that will only store 50 characters. But the way C stores a string, which is just a selection of characters and digits and things that you're not going to do any maths with, is it has to put a terminating character at the end. So that means you can only store 49 items inside the variable name. So if my name was longer than 49 characters, this program will act strange and crash. So let's do that. So that's 50 characters. 1, 2, 3, 4, 5. That's 55. Now it must be that GCC does some sort of memory protection, or there's just nothing else after it, because that should have like knackered something. In fact, it has done. You saw it briefly just then that it crashed. So if we go to this window, you can see that the program crashed. We got a segmentation violation. We'll deal with weird errors later. But this is trying to tell you what happened in the CPU to cause this to crash. It happened because I wrote past the end of this array. And the way C works, the next item after this array, I think is this code here. So I overwrote something with my text. I possibly overwrote bits of the code at the end that tidy up the program before it exits back to DOS. Whatever I did, I knackered my machine. Fortunately, it didn't crash the whole thing. So there you are. If you see this, it means your program crashed. So far we've done some simple little test programs just to get used to the IDE and how it all works. If this was quite strange and confusing, it's fine. Okay, some of you are probably a bit lost, and you're probably wondering how I even know what to type in. Like, where'd that code come from? You could see after a bit I was kind of confused that I didn't know how to type the right C, but I knew what I wanted to do. So let's talk about that kind of thinking, because nobody ever does. I'm sat here casually making code up as I go along. Clearly I've done this kind of little routine multiple times, almost like I do it at work to a group of equally confused kids who've got the attention span of a goldfish. You lot have a bigger attention span, so stick with me for the next couple of minutes so I can explain how to think like a programmer. So the hardest part with programming is figuring out what to type and what instructions to give the computer. You might know you want to make something, but have no idea how to do it. Tutorials on programming tend to focus too much on the end result and not the process. Let's look at the process itself for a moment. The trick to programming is every computer program, no matter what it is, follows the same simple logical components. We've got instructions. Computers follow instructions that we write in code. There's a sequence. You need to put the instructions in the correct order. And there's selection. The instructions might need to make some simple yes or no decisions. Or you might have iteration, where it might be more efficient if the computer repeats instructions rather than us typing them out multiple times. And all computers work with the following components. They all have inputs because computers process data, that's their function. The original computer was created to help calculate the census. I made a video on that nobody ever watched. I think I don't know, weird, but go watch it, get some view counts up on it. But anyway, the data has to get in the computer somehow. There's processing. The code that we write has to process the inputs. That's the point of the program. And then there's output. If your program doesn't make any output, there was no point running it. It's got to do something. And then you've got storage, where the inputs and the code and the outputs have got to be stored somewhere so that it can be worked on or kept for later. Which is fine, but a bit vague and not that relevant to what we're trying to do today. Because how are you supposed to know what code to even type in and what inputs are needed? That's where we can apply some thinking strategies. There's 3, but you sort of mix and match them as you feel appropriate. They're also nothing new and weird. You do these in your daily life as a thinking, living person. What we've got is pattern recognition, because people are amazing at spotting patterns. Visual patterns, sound, people's behaviour. We're just wired up for some reason to spot patterns. Well, you can use that same thinking to find patterns in how something works. We've then got abstraction, because we're good at making broad generalizations about something and ignoring the fine details that aren't relevant. We do it all the time. It's how we remember anything. If there's too much input, your brain sort of filters out the important stuff. The other thing that we can use is called decomposition. And it's the main skill that you need as a programmer. This one is a little bit different. Sometimes something is too big to do. But if you think about it, you can break it down to smaller pieces. And then those smaller bits are supposed to be easier to solve. But they might not be. So you might need to break those down again. And if you keep doing this, eventually you get to little tiny pieces that are so simple, they can't be broken down any further. And they're actually the instructions you give the computer. It feels like you're making more work by breaking this into smaller pieces, but the idea is each smaller piece is easier to deal with. So let's see all that abstract waffle in action. It'll make a bit more sense, because that was far too abstract. So we'll make a game. Let's make a really simple game that kind of shows off some of the basics of writing some code. We're going to make a very basic guessing game. The idea being that it's one of those things where you think of a number, the other person thinks of a number, and you play higher or lower until one of you gets it, well, until the person gets it right. So in this situation, it's going to be a one-player game. The computer is going to think up a number, and then we have to guess it. And the computer will give us some hints. It'll either tell us if the number is too high or too low, or if it's correct. Now, by describing it like that, I've already done abstraction and a bit of decomposition, because I've thought up a sequence of what I want to do, and then I've broken that down into some basic steps. I've not worried yet about how I'll do any of this stuff, but I've got a vague idea of how to progress step by step. I got here by imagining the game working. I'm already familiar with this general idea, which makes it a bit easier. So we can sort of mock up what we want it to look like. So I've got a new file open, and I'm just going to start by describing what I want the game to look like. So somehow the computer is going to think up a number. Then it's going to ask me to make a guess. The player is then going to type in the guess. Then the computer has to work out whether it's the right one or not. And then it'll carry on until we win. So there's a few basic steps, and now we need to see if we can break that down any further. So computer will think up a number, probably not. It'll ask the player to make a guess, again that's fairly good. Player will type in their guess, that's just how it works. Computer will work out if the guess is correct or not. Well, there's three possible options. So there's three options that we could have. And then we've got carry on until the player wins. Well, that's not how we write code. You don't get to the end of something and then tell the computer carry on. You do it backwards. You tell it what you're going to repeat before it starts repeating it. So the parts of this that need repeating is everything after where it thinks up a number. There's a way of indenting it, and it's not to press tab. I cannot remember the button to indent code, so we're just going to do it by pressing tab lots of times. Now if you look at the structure of this code, it's indented, and it looks a little bit like how Python lays its code out, because that's the point. That's how this kind of works. C doesn't care about indenting code, but it's helpful if you write stuff like this so that you can visually see which parts of the code belong to other parts. And now we've got a vague idea, we can sort of start trying to code this up. Right, so we now need to add some basic C boilerplate code that most C programs have that are quite basic. So we need that, and then we need a main function, and everything will live inside it. So the first thing we need to do is make the computer think up a number. These are small tasks. This is something that you can find by like reading the Sacred C book, or by just Googling the internet or asking someone. And it turns out there's a function that does it. But we need to store that number so we can use it later on. So that will create for us a random number between 1 and 100. It's not mathematically the best way of doing this, but nobody cares, we're just doing a simple program. We then need to print out some sort of beginning welcome to the game type of thing. And now what we need to do is this part here. We need to repeat the code until the game is over. We're going to do that a really simple way using a loop. We're going to use an endless loop that never stops. Inside there, we now need to ask the player to make a guess. Now, all that's doing is writing text on the screen. We actually have to allow the user to type in their guess. And we need to store it somewhere. So thinking about the data that we're going to keep in our program. So we'll have another variable, and we'll set it to 0, because we have to set it to something. And that bit of C is how you read in a number. So what we've done already is we've thought up a number, we've repeated, we've asked the player to make a guess. The player can now type their guess in. We now need to work out if the guess is correct or not. So the guess could be too big, too small, or it could be correct. We do that by using an if. So we can say if guess is bigger than secret. What we're going to do is print that your guess is too big. If it's too small, we'll tell them. If it's neither too big nor too small, logically it has to be correct. So we don't need to do another if, we just do else. And in there we can do... And now we need to leave the loop. It's an infinite loop, so we have to break out of it by using the word break. This is not the best programming style, however it's quick and it's simple. An alternate way could be to have a variable called game over that we set to 0, and we say while game over is not 1, and then down here we just set game over to be 1. It does the same thing. So if we get here, we are outside the loop, and I feel I've got an extra bracket somewhere. So that's a problem with C. that you end up with lots of little brackets trailing around the end. So what you can do sometimes is you can say what they belong to. So I want to print game over, which has to happen after the while loop is finished, so it can go here. This should be all our code. So what we'll do now is we'll save it, and then we'll run it, and we'll let it compile, and we'll see what happens. While it's compiling, we'll have a cup of tea. So it compiled and it said no errors. And now we've got a screen, and it looks a bit like what we want. It says, please guess the number. It's between 1 and 100. So I'm going to type in my guess. I'm going to type in 50. My guess is too big, so I'm going to type 25. My guess is too small. So I'm going to pick 35. That's too big. I'm going to pick 30. That's too small. I'm going to pick 32. That's too small. 34. That's too big, so it must be 33. There we are. And you can now see that I went through it and I figured out the number, and it said it was correct. So I typed in 33 and it said the number that I guessed was 33. Now, hopefully that wasn't completely confusing to you. I know that if you understand C, that was incredibly basic and simple, but this is just like the first video to get things going so that we all kind of know where we're starting from. But if that was confusing, I've written it down in my website that I'll put a link down there somewhere. If you go read through that, it'll have the code you can look at and a bit more detail that is kind of boring to show in a video. Having had a taste for some basic DOS development, where do we go next? Because this is a powerful 32-bit CPU with a maths coprocessor. This is no longer a weedy little Z80 where we've had to do like really complex maths. Simple text input and output isn't Doom. It's what we did in BASIC with those cool Usborne books, if you remember those from the 80s. My ZX Spectrum could do this. So we need more information, because currently we're just kind of playing around in text mode. But we also need to limit our expectations for now, because this is a complex 32-bit CPU with a maths coprocessor. It's not a Z80 with a handful of instructions that you can learn in a weekend. Getting to the cool looking stuff will take a bit of effort. The good thing about learning something 30 odd years old though, is that all those tricks and techniques that once were like being discovered or were trade secrets or just people didn't want to tell each other, they've all been discovered and written down, and we can just go and find it. But our challenge is finding that information that's 30 years old. It's mostly out there, but it's not always easy to discover. We need to go into those little weird corners of the web that time forgot. Someone forgot to switch a server off and it's still got ancient web pages on it. Do a bit of digital archaeology. So let's go on the computer and we'll have a click around the internet, see what we can discover. So we need some ancient information from like back in 1996, 5, that kind of era. I found one website, this one, which has still got its archives open. And if you know a website that no longer works, it's probably in here. There is also the bit with the books. So if I type in here, programming MS-DOS, learn 3D graphics programming on the PC. Advanced MS-DOS programming. You see, here's a book. Because of all the copyright problems that they were having, you now have to actually log in to read the book. You can no longer just download the PDF. Okay, so it appears they've fixed one of the problems that they had about a month ago when I was trying to do this before, where you couldn't actually log in to rent a book. So I can now read this book, but it's got to be inside their browser. So if I try and borrow it, let's see if that works. There we go, so now I can click through this book. This could be a decent book, I don't know. I can now read it for free. Of course, if you are any good at finding stuff on the internet, I'm sure there's other ways of locating old copies of books. One legitimate way is to buy them off the internet. So I actually used Amazon for its original purpose, which was for selling books. And I found 2 really old DOS books, which I've tried to buy. But if you look at my screen, there's a little bit of a problem going on here. Like, this one is apparently arriving 18th to 23rd of November. Currently it's the 17th. So hopefully this book will turn up soon. This one, your package may be lost, which is fantastic. We're very sorry your delivery is so late. It may still arrive. You can request a refund now. Computer Organization and Assembly Language Programming. Oh look, ignore the fact it's purple. Pretend I've not clicked this in the past whilst waiting for that book to turn up, and oh look, oh no, this is a thing, it's not the book. That book actually hasn't been scanned in by anybody. Don't even think it's on the Internet Archive. There's lots of books with very similar names. Computer organisation. Now, another way of finding information off the internet was to actually ask other people. This was way before Stack Overflow existed, but it was just as harsh out there, and it wasn't even like Reddit existed. Instead, there was Usenet, because it's still been archived, and you can click around it. This is comp.programming from 1995. If you click around, you'll find some that are interesting, like C, C++ programming. What's this? So here's a C programming course. If you don't have Mosaic, you can still read these files, use links, which is an ancient text-based browser. What else have we got? I found this one, Appropriate First Programming Language for a Kid, back in 1995. So we've got a 12-year-old kid interested in computers. He's used Logo already. He wants to learn QBasic. What's a good book for basic programming? Okay, so this is still the 90s. We're still sort of thinking basic is the language. There's always that one person that suggests, oh, you need to learn C. There's no way I'd teach 12-year-olds C. Teaching them Python is hard enough. Insane people that have never dealt with children think that they should learn C. No, that's not a thing. Back to your regularly scheduled waffle. Yeah, I learnt programming with BASIC. I was 9 years old, but after 6 years I got a PC and discovered Pascal, and I found it great. Pascal's not bad. Pascal's now obsolete, but back then, that's what I was learning. They taught that me at college. Not bad. But it's like I explained earlier, you need to know the basics behind programming, then it doesn't really matter on the language. But anyway, I think you get the point that if you scrounge around the internet, you'll find places with ancient information that is quite useful. So, as that vaguely unstructured, distracted ramble hopefully got across to you, is that if you find a good site to do with programming, you need to either download a copy yourself, bookmark it, or at least write the information down so that you've got it for your own information. Like, I'm making my own notes for future reference, and when I've collected them together, I'll put it online. I guess we sort of need a Wikipedia for programming and other technical computing info, rather than just trying to stuff it into Wikipedia, because it'll just get lost. This video is a bit like the first edition of those multi-part kits that you could use to subscribe to. You know, where it was like, build the Titanic piece by piece over 47,000 episodes of this magazine. Part 1 is a turret and a tube of glue. You know, there's a lot of waffling setting it up to let you access the later editions. I think this series will consist of short and mini programs where I can focus on 1 or 2 small ideas, rather than working on some monster-long project. It's going to be some sort of retro DOS digital playground type thing. It needs a name. Please suggest names down below. I can't think up names, they're awful. I tried ChatGPT and it just glued words together and it sounded awful. I definitely want to make it interactive though. So give me some ideas about what I should be learning and making videos about. What direction should we go in? Should this be computer sciencey algorithmy type of stuff? Demo scene effects? Bearing in mind I need to learn how to do any of that first. Or something else? What should we do? Now, as a final sort of taste of future content, I thought it'd be fun to do a little mini program that I could use as the titles for these videos. And I sort of managed to make this thing that you're looking at now, which I'm going to explain its workings of in the next video. You see, you're not watching a PC boot up. You're watching a recreation of the BIOS boot screen that I programmed. It kind of came about because I was just a bit bored and I wanted to learn how to write some code again. And I figured I could just print out a BIOS screen and it might look interesting. But then I noticed that there's a logo in the corner. And this is all running in 80 by 25 text mode, not graphics mode, because it's the BIOS of the machine. It assumes you've just got a crap EGA graphics card in the thing. And yet it's drawing that little Energy Star logo. So I fell down a massive rabbit hole working out how they did that. And that was really actually quite interesting. It's kind of the deep, weird technical stuff that I really like doing. So we'll look at that next time. And until then, I'll see you later. Right, we can cut between all these different things. Ooh, this gets fancy now.